This video will cover scientific notation. Scientific notation is a way to represent a number in a slightly different form. In scientific notation, the number will have a decimal part. This is essentially the value of the number, and then an exponential part here, a times 10 to the something, that describes the order of magnitude. It essentially moves the decimal point in the number. Scientific notation is a convenient way to represent numbers that are either very large or very small, and also have the advantage of clarifying significant figures. When there's a number that has an ambiguous number of significant figures, scientific notation can be used to specify it exactly. Both of these numbers are exactly the same. They're just different ways of representing them. So you might be asked to use scientific notation in one of two ways. You might be asked to change a number from decimal notation, which I've shown here, into scientific notation, or vice versa. To change a number from decimal notation to scientific notation, identify the first non-zero digit, in this case 4. Put a decimal point after that number if there's more than one digit, and then add any remaining significant figures, in this case the 2. But these trailing zeros aren't significant in this case, so just 4.2. The next part is to work out the exponent. So you're going to write times 10, and then you need to figure out what number needs to be there. In this case, if we take 4.2 times 1,000, then we'll end up with 4,200. 1,000 is 10 to the 3. Another way of thinking about it is we move the decimal point 1, 2, 3 spots to write it in scientific notation. And when we move it 3 spots to the left, it's 10 to the 3. The way I pay attention to signs of positive or negative exponents is a positive exponent is greater than 1 and a negative exponent is less than 1. But 4,200 written in scientific notation would be 4.2 times 10 to the 3. Now in this case, again, 4.2, but because there's a decimal point, these trailing zeros are significant, and I need to put all of the significant figures down. There are 3 trailing zeros that are significant, so 4.2000 is the decimal part of the number, times 10 to the, in this case, 1, 2, 3. Okay, this number is less than 1. This is going to be a negative exponent. Again, go to the first non-zero digit. 3 point, include all of the remaining significant figures. In this case, all of the digits. The interior zeros are always significant, and then 8, 2. Now, 0.003 is not the same as 3, so I need to add this exponential part to modify it, and it's 1, 2, 3. This is going to be negative 3. A small number less than 1, so I should have a negative exponent. Scientific notation will always have one non-zero digit, and then if there's more than one significant figure, a decimal point in any remaining digits, and any numbers that are displayed in scientific notation are significant. If you're changing back, it's the same process. I like sorting out the exponent first. So in this case, a negative exponent, this number is going to be less than 1, so 0 point. And I need to move this decimal spot 1, 2, 3. So there's going to be 2 zeros. And then I'll write out the numbers, 1, 8, 4. So this, it's moved over 3, 10 to the negative 3, 1.84. Now in this case, we have the 9, 0, 0. Times 10 to the 2 means that decimal point, 1, 2, this is 900. And this is one of the reasons we might write it in scientific notation, is this looks like one significant figure, but I really wanted 3. Okay, so it's ambiguous in decimal notation. That might be a reason to represent 900 in scientific notation. So 1, 2, 3, 4, 5. So 4 zeros and then a decimal point. This trailing zero I need to include in the number. That's a significant digit. And so I needed to include that here. Okay, go ahead and pause the video and answer this question to check your understanding. Okay, so first non-zero digit, 1 point. The 8 and 2 are significant. This trailing 0 is not significant because there's no decimal point. And then my exponential component is times 10 to the, and this is going to require a 3. And whether it's positive or negative, we move to the left, so it's positive. I like to just think about it as 1,820 is more than 1, so it's going to need a positive exponent. So times 10 to the plus 3. You don't need to write the plus. So in this case, here, this is incorrect because this 0 wasn't significant in the original number. If I wanted to express this as 4 significant figures, this would be appropriate. And these two are incorrect. If I had 1.82 times 10 to the negative 3, it would be 0.00182, not 1,820.